natural numbers. This is the section where we're going to review our order of operations. We're going to review some vocabulary, and we're going to bring back all those skills we needed in Algebra 1. So in number 1, you have a negative, a negative. Well, two negatives become a positive, so you get 7.2. In number 2, you have a minus again. So that is the subtraction property of a negative, which tells you it becomes a positive. So we get 4. In number 3, you're adding two opposites. So you get a larger negative number. In number 4, you are multiplying a negative times a negative, which I hear calculators coming out. Does anybody in here need a graphing calculator for the school year? No, we're good. We all have graphing calculators? Okay. A negative times a negative is a positive, and 3.4 times 2 is 6.8. And number 5, negative 15 divided by negative 3 is negative 5. Number 6, negative 2/5 plus negative 3/5. Well, they're both negative. So even though this negative is down in the bottom, you can think about it as being up top. So it's really the same as negative 2 plus negative 3 all over 5 because they have a common denominator. So you get negative 5 over 5, which reduces to negative 1. Yes. Negative 5.4. It's multiplying. You're okay. I was like, wait. You're good. At least you're trying to pay attention to me. Okay. So the next thing we're going to talk about is the number system. So our number system is broken up into a couple different parts. So the first part is the natural numbers. The natural numbers are the counting numbers. That's what you learn as a little kid. So the very first thing you learn when you're learning how to count are the natural numbers. So you say, okay, 1, 2, 3, 4, and then you get up to 10, and then one day you go up to 20, and then you can count to 100, and you make your parents really proud. Well, as you work through learning, at some point you also learned that there was the number 0. The number 0 is known as a whole number. And a whole number is really just all the counting numbers plus the number 0. As you got older, and probably around 2nd, maybe 3rd grade, you learned that there was this thing called negative numbers. We call those negative numbers and positive numbers together the integers. We call the negative and positive numbers together the integers. Integers are the natural numbers, their opposites, and 0. Integers are the natural numbers, their opposites, and 0. the rational numbers are essentially our fractions and decimals that can be written as fractions and decimals. So we have decimals that cannot be written as a fraction. That would make them irrational. But any fraction that can be written as a decimal or decimal that can be written as a fraction is a rational number. And if you think about what a fraction represents, it represents division. You'll notice in the definition of a rational number, it says a quotient of integers. Quotient is the formal mathematical word for division. So you'll notice that the rational numbers as a short symbol are the letter Q, again standing for that quotient. It's not an R because we use the letter R for real numbers, meaning everything. We also have irrational numbers. Those are square roots that can't be simplified. That's the number pi, e, or any decimal that cannot be turned to a fraction. I like a Venn diagram for representing this collection of real numbers because it helps to see that one includes the other and then includes the other and includes the other. So we start at the top and we start with the real numbers. So everything you've learned about in math class so far is a real number. This year, we're actually going to learn about imaginary numbers, and our box and Venn diagram is going to expand. But for now, you have the real numbers. And the real numbers can be broken up into two different categories. The first category is the irrational numbers. And the second category is the rational numbers. And these two categories cannot overlap. So like this line cannot move into that line and the other line cannot move in either. So the real numbers are broken into two categories, the rational and the irrational, and they do not overlap. However, the rational numbers can keep getting broken down into a more exclusive group. So some rational numbers are also identified as integers. Some integers are also whole numbers. Some whole numbers are also natural numbers. So the more inside the bubble you become, the more exclusive you are. If it is a natural number, then it also is a whole number, and it also is an integer, and it also is a rational number. So as you move out and up through the bubble, it also includes more titles. So it's kind of like as you grow up, right? You're a kid. And then as you become an adult, sometimes you become a spouse. Then after you become a spouse, sometimes you become a parent, and parents become grandparents, and so on. So as we grow up, our titles can change. Same with as you grow into other categories. So what I want you to do is take a minute and label the next 4 problems with as many labels as you can see or think they fit into, and then we'll check them. Pi is an infinitely long decimal that can never have an end. Therefore, it's irrational and real. So again, it works from the inside of the bubble and up. You are essentially everything into the smallest category and above. Okay, we have properties of real numbers. The properties of real numbers are properties that tell us we can add and subtract in certain orders. So the first property is closure. Closure says that if you add 2 real numbers together, you get a real number. It also says if you multiply 2 real numbers together, you maintain a real number. The commutative property says that the order with which you add does not matter. So A plus B is equal to B plus A. You can think of the word commute in the word commutative. You commute from home to school, school to home. The distance between the two doesn't change depending on the direction. Same is true for multiplication. A times B equals B times A. The associative property represents grouping. So you can change the way you group your problems. The identity property says that if you add 0, you will still get A, so it doesn't change its identity. And if you multiply by 1, you still get A. So the identity property is essentially saying you can add or multiply by this number to get where you were back. It doesn't change its identity. And the inverse property is how you get the identity property. So the inverse of A is negative A if you're adding, and the inverse of A if you're multiplying is 1 over A. And then the distributive property, we all know the distributive property. The distributive property says you can distribute A to B and A to C and still get AB plus AC. Okay, so let's take a minute. Is anybody still coming? Okay, so let's go through and talk about each of these. In number 13, you have -7 on the outside. That doesn't change from one part to the other. On the inside, you have 2 times 5. Then you have 5 times 2. So if you change the order that you are multiplying inside parentheses, that is the commutative property of multiplication. So I need 3 pieces of information. I need you to tell me commutative, and I need to tell you to tell me if it's multiplication or addition. So when you're doing these and practicing, you need to make sure you put the property and then if it's multiplication or addition. 14, we have 3 on the outside. 8 plus 0 equals 3 times 8. So the difference is we're adding 0 versus not adding 0. So that is the identity of addition. In 15, the difference is multiplying by 1 versus not multiplying by 1. So that is the identity of multiplication. In 16, you need to notice how the grouping changes. The operations are addition. So if the grouping changes and we are adding, then that makes this the associative of addition. In 17, what you notice is that the 3 is outside, and then the 3 is multiplied by both parts. So if it goes from outside to multiplying by both parts, that is the distributive property. And last but not least, we have 1/5 times 5 to get 1. When you get an answer of 1, 1/5 and 5 are called inverses of each other. So that is the inverse property of multiplication. Questions at all on any of our properties? So that sums up what we're going to do for today. Your homework is the next page in your notes packet. So we will pick up with notes day 2 on Thursday. So you need to be looking out on Fusion, and or if you like to get it done earlier, you can look on my YouTube. It'll get posted probably by 8:30 on YouTube. Fusion takes me a little bit longer into the day.